Hey there, space fans! Welcome back to StarTalk. We're thrilled to have you join us for another cosmic adventure. Whether you're a seasoned space enthusiast or just starting to explore the wonders of the universe, you're in the right place. Today we're diving into the heart of the Sun, exploring one of its most awe-inspiring phenomena, coronal mass ejections, or CMEs for short. These colossal bursts of solar wind and magnetic fields are not only fascinating but also crucial to understanding space weather. Get ready for an explosive journey. We'll witness the raw power of the Sun as it unleashes these massive eruptions. It's like watching a cosmic fireworks show, but with stakes that reach all the way to Earth. Imagine billions of tons of superheated plasma erupting from the Sun, hurtling through space at millions of miles per hour. These CMEs can travel vast distances, impacting everything in their path. That's a CME, and they're not just a sight to behold, they can have a real impact on our planet. From disrupting satellite communications to causing power grid failures, the effects of CMEs are far-reaching. We'll break down the science behind these solar storms, from their birth in the Sun's atmosphere to their potential effects on our technology and the stunning auroras they can create. These natural light displays are one of the most beautiful consequences of solar activity, so buckle up, because things are about to get exciting. We're about to embark on a journey that will take us from the core of the Sun to the skies of Earth, revealing the incredible power and beauty of our star. We'll be back after the break to delve deeper into the world of CMEs. Stay tuned. There's so much more to discover about these fascinating solar events and their impact on our world. So, what exactly are these coronal mass ejections I keep mentioning? Well, let's dive into the fascinating world of solar phenomena to understand them better. In simple terms, a CME is a massive burst of solar wind and magnetic fields rising above the Sun's corona. These eruptions are so powerful that they can release billions of tons of solar material into space. Think of it as the Sun sneezing, but instead of saliva, it's spewing out a giant cloud of electrically charged particles. This sneeze can travel millions of miles through the vacuum of space. These particles race through space at incredible speeds, sometimes reaching Earth in just a couple of days. Imagine a storm of particles traveling at speeds of up to 3 million miles per hour. Why should we care? Well, when these charged particles hit Earth's magnetic field, they can trigger a cascade of effects, some dazzling and some potentially disruptive to our technology. For instance, they can cause geomagnetic storms that may affect satellite operations, power grids, and even navigation systems. But don't worry, it's not all doom and gloom. Our planet's magnetic field acts as a protective shield, absorbing and deflecting much of this solar energy. CMEs are also responsible for the breathtaking auroras that paint the sky near the poles. These natural light displays, known as the northern and southern lights, are a direct result of solar particles interacting with Earth's atmosphere, so there's beauty to be found in these solar storms too. They remind us of the dynamic and ever-changing nature of our Sun, and the incredible forces at play in our solar system. Now, CMEs don't just appear out of thin air. They're often associated with another solar phenomenon, solar flares. Picture solar flares as sudden, intense bursts of energy on the Sun's surface. These bursts release a tremendous amount of energy, equivalent to millions of nuclear bombs exploding at once. Sometimes these flares act as the trigger for CMEs, propelling them out into space. It's like the flare provides the initial push, sending the CME on its journey towards Earth or other planets. Understanding this connection between flares and CMEs helps scientists predict when these solar storms might be heading our way. It's a dynamic and complex process, but unraveling the mysteries of the Sun's activity is crucial for protecting our planet from the potential impacts of these powerful events. CMEs are not all created equal. They come in different sizes, speeds, and carry varying magnetic fields. Some CMEs are relatively small and slow, while others can be monstrous, spanning millions of miles across and traveling at speeds of several million miles per hour. And the magnetic field of a CME is particularly important. Imagine it as a giant magnetic bubble surrounding the ejected plasma. This magnetic field interacts with Earth's own magnetic field, and the orientation of this interaction can dictate the severity of the impact. The stronger and more aligned the CME's magnetic field is with Earth's, the more intense the geomagnetic storm it can trigger. Section 5: CMEs and Earth, a magnetic dance with technological consequences. When a CME, or coronal mass ejection, collides with Earth, it doesn't actually crash into our planet. Instead, it interacts with the Earth's magnetic field, creating a fascinating yet potentially hazardous dance of particles and energy. The Earth's magnetic field acts as a protective shield, deflecting and absorbing the charged particles from the CME. This interaction can lead to a phenomenon known as a geomagnetic storm, which can have significant consequences for our planet. During a geomagnetic storm, the magnetic field is disturbed and shaken, much like a ship being tossed around by rough seas. This disturbance can cause a variety of effects, both beautiful and disruptive. One of the most visually stunning effects is the aurora, or northern and southern lights, which are caused by the interaction of solar particles with the Earth's atmosphere. However, the same geomagnetic storm that creates these beautiful lights can also wreak havoc on our technology. Satellites, which orbit the Earth and are crucial for communication, navigation and weather forecasting, can be particularly vulnerable. The increased radiation from a geomagnetic storm can damage their electronics and disrupt their operations. On the ground, power grids can experience surges of electricity, similar to a lightning strike, which can overload the system and cause blackouts. This can have a cascading effect, leading to widespread power outages and disruptions in daily life. The increased radiation can also affect high-frequency radio communications and GPS signals, which are essential for aviation, maritime navigation, and even everyday activities like using a smartphone. Power grids, which are the backbone of our modern infrastructure, can experience overloads and failures, leading to blackouts that can last for hours or even days. This highlights the vulnerability of our technology to the forces of nature. It's a stark reminder of how interconnected and dependent we are on technology, and how the sun, 93 million miles away, can have a profound impact on our daily lives. The dance between CMEs and Earth's magnetic field is a powerful example of the dynamic relationship between our planet and the cosmos. Section 6: Auroras, the dazzling light show from CMEs. While CMEs can pose risks to our technology, they also bring beauty to our skies in the form of auroras, also known as the northern and southern lights. These vibrant displays of light occur when charged particles from a CME collide with atoms in Earth's atmosphere. Imagine these particles raining down on Earth's poles, energizing oxygen and nitrogen molecules. This energy is then released as light, creating the shimmering curtains of green, red and purple that dance across the night sky. It's a spectacular reminder of the interconnectedness between the sun and Earth, and the awe-inspiring power of our nearest star. Section 7: Space Exploration and the Challenges of CMEs. As we venture further into space, understanding and predicting CMEs becomes even more crucial. Astronauts on missions beyond Earth's protective magnetic field are particularly vulnerable to the radiation from these solar storms. Exposure to high levels of radiation can be harmful to human health, increasing the risk of cancer and other health problems. Space agencies like NASA are constantly monitoring solar activity to ensure the safety of astronauts during spacewalks and on future missions to the Moon and Mars. It's a constant challenge, but one that's essential for the future of space exploration. Section 8: Predicting the Unpredictable. The quest to forecast CMEs. Predicting CMEs is a bit like trying to predict the weather here on Earth. It's an inexact science. Scientists use a variety of tools, including space telescopes and computer models, to monitor the sun's activity and try to anticipate when and where a CME might erupt. By studying sunspots, solar flares and other indicators, they can issue warnings and forecasts, giving us some time to prepare for potential impacts. However, CMEs can be unpredictable, and their paths through space are not always straightforward. It's a constant challenge to improve our forecasting abilities and stay one step ahead of these solar storms. Section 9: CMEs, a window into the sun's power. Coronal mass ejections may seem like distant events, but they're a powerful reminder of the sun's influence on our planet and our lives. By studying these solar storms, we gain a deeper understanding of our star, its behavior, and its potential impact on our technological world. As we continue to explore space and rely more heavily on technology, unraveling the mysteries of CMEs will become increasingly important. So the next time you see a dazzling aurora, remember that it's a beautiful reminder of the sun's awesome power and the importance of understanding our place in the cosmos. That's it for this episode of StarTalk. Keep looking up.